Today we're going to show you recursion. The most famous recursion, or most famous simple recursion problem is the Fibonacci sequence. If you go to Wikipedia here, you can see it's defined as the previous number and the one before that added together to give you the current number, or n minus 1 plus n minus 2 is n. All right, so let's go right into it. So we'll define a method, and it has to be, because we're looking at what was in the previous versions of the number, it would make the most sense to do this recursively, although I believe most things in recursion, if not all, could be done without recursion, which would be usually more efficient. Problems are easier to look at with recursion because they could be much more simply written. So we'll do recursion since that's the goal. So let's call it fib for Fibonacci, and we're going to pass it in the initial numbers from the sequence, which is 0, 1, and then we're going to have a counter so we can add up the number of times that we've already performed the sequence. So in this case, our counter is going to start at 0, and what number in the sequence we want to go to, let's just say 20. We'll go ahead and let the IDE do the heavy lifting, Control dot to generate the method, but let's give it some more descriptive variable names. So let's just say A is the first letter of the alphabet for the first number of the sequence. B, we know B is sequentially after A, so that'll help us understand that. And then we want our counter, and then we want to know sequence to stop at. Let's call it stop. All right, so the important thing to know with recursion is you have to stop recursion at some point, or else it's called infinite recursion. So let's define our stopping condition. It's usually right at the start. Let's say if, let's say counter is less than or equal to stop. That's how many times we want to do it. Once that condition's met, we won't recurse anymore. Now, a lot of recursion methods will do the task first, and then they will recurse after. In this case, that would kind of keep things going in order, like a regular for loop. More interesting recursion algorithms, which we'll cover in other videos, like sorting, oftentimes do the recursion first, then the task after, and that would actually make it like a reverse loop where a lot of logic takes place, but nothing is actually done until the end as we're pulling back out of recursion. So not to confuse anymore, we'll go the simple way since this is a simple algorithm. So let's write to the screen. Console.writeLine, and we'll do, we want to print out the, I guess we'll do A. That's going to be the sequence item. And then we're going to go ahead and recurse to find out what the next sequence item is. Let's do fib of, this is actually going to swap B and A, because remember it's n minus 1 plus n minus 2 is n. So we're going to swap it to get the previous value, B, and the next one's just going to be A plus B. And then we can go ahead and put in the counter, which is, we're incrementing it, so counter plus 1. And stop doesn't change because you want to keep that value through every iteration. That's it. Let's run it. F5. And there you have it. All right. Well, thank you very much.